Hello, my name is Negar, and together with my collaborators at Northwestern University, I'd like to introduce our research on characterizing photorealism and artifacts in diffusion model generated images. Now, I'd like to bring your attention to a photo of Barack Obama having burgers with a couple of friends. They seem to be having fun. However, something looks off. Is that how you're supposed to grab a burger? What is going on with this image? Also, look at his other hand. It looks funny and malformed. What about his super shiny forehead? And what are these shadows in Obama's color? This flag also doesn't look quite right. And isn't that great that there is a ghost sitting at the next table? So yes, unfortunately, this casual evening of Barack Obama and friends enjoying their deep discussion and deep fried food is of course a deep fake. So if this dinner never actually happened, how was it created? One of the most powerful methods behind these AI-generated images are diffusion models. They were first really introduced for image generation in 2015. Specifically, when denoising diffusion probabilistic models were introduced in 2020, there was this massive increase in diffusion models, both in research industry and also in media. What people currently widely use to generate images are diffusion models. They are commercially available, they're much better in producing impressively realistic images, and they have high controllability beyond what can be done by GANs. While diffusion models achieved impressive results, we need to remember being good at removing noise doesn't equal understanding reality. Look at this image, for example. We see a full body shot of a man climbing down the stairs. The first glance, everything is fine. But when we pay a little more attention to the surroundings, we see that the stairs don't quite line up. Just like they mess up architectural laws, they have no understanding of who these politicians are or what situations make cultural sense. That's how we end up with perfectly photorealistic images of events that either never happened or could never happen. In fact, nowadays, these images are a powerful tool for misinformation. So what do we do when we have many AI images and videos coming our way daily? One way is to use machine learning detection algorithms, but they're brittle and not robust enough. First of all, there's high frequency changes in generative AI architecture requires constantly updating the detection methods. Then, basic changes like simple cropping or compression can reduce accuracy to near random. Moreover, each generation method leaves different patterns. Detection performance significantly drops when architecture changes. On the other hand, these classifiers often simplify image authenticity as a question of real versus fake and ignore the critical reasoning about component parts and sub-questions that an ordinary person may consider when evaluating an image's authenticity. So what about us humans? Well, here's the key difference. Unlike these models, we actually understand how things work in the real world. When we see an uneven stairway, we know instantly if something's off. When we see a photo of a politician at an event, we can tell if it makes historical sense because we understand social context. But let's look at this paper published by Nightingale and Farid, which showed when it comes to later LinkedIn style portrait photos, people actually couldn't tell the difference between real and AI generated faces. Top rows are real images and bottom row is AI generated images. This gives me a nice opportunity to define photorealism. We're going to define photorealism in an empirical way from a psychophysics perspective that is about the proportion of human observations that incorrectly categorize a fake image as real. Now that we have a sense of what photorealism means and how it connects to diffusion model failures, let's look at how our research breaks this down into two main parts. First part focuses on creating a taxonomy to categorize photorealism and diffusion model generated image failures. The idea is if we can do this, then we can build a language for communicating these failures. In the second part of our research, we conducted a large-scale experiment to answer questions about human detection of AI generated images, both qualitatively and quantitatively. Now, this is a snapshot of the final taxonomy that we created. We categorize artifacts in 5 different categories. We have anatomical implausibilities, stylistic artifacts, sociocultural implausibilities, violation of physics, functional implausibilities, Now, the full description of these, along with many examples, are published in our how-to guide linked below. Now, let me tell you how we built this taxonomy. Our taxonomy emerged through a couple of different steps. So first, there was background research on academic literature, on AI-generated images, online forums, and viral deepfakes. Then we created and curated thousands of images. We systematically prompted them in Midjourney and Firefly. We created custom pipelines in Stable Diffusion. And then we crowdsourced data collections. We hosted a website online that anyone can come to and interact with and try to see how well they can distinguish real from fake. They participated based on their own interest and curiosity, and they were not paid. We analyzed this data and used the results to refine our initial taxonomy. And then we updated the taxonomy. It was this continuous process where we're constantly refining our stimuli and our taxonomy. Overall, we had 599 images. We generated and curated these images to represent diverse scenarios across 4 dimensions of scene complexity: portraits, full bodies, pose groups, and candid groups. So this is a screenshot of our website. It's called Detect Face. We gathered data from 50,000 participants and 750,000 observations. And we had more than 30,000 comments from people. So we have a lot of observations. Now let's see how photorealistic these images are. Start by looking at the distribution of accuracy across images, and then accuracy by context, and display duration of an image. And then we are going to look at the human curation influence on photorealism. What I have here is a graph with accuracy on the y-axis, and then on the x-axis, I'm showing you the counts per accuracy levels on AI-generated images and accuracy on real images. Average accuracy is 76% for AI-generated and 74% for real photographs. But what you can see is that there is a big distribution. If you look at the top decile of the AI-generated images on the left, some of these almost look like cartoonish, and so in the analysis, we removed anything that was detected with above 90% accuracy, just because they maybe weren't even photorealistic to begin with. Here we split our data on the different scene complexities. And so we can look at portrait versus full body versus pose group and candid groups. People's accuracy in detecting AI images was lowest for simple portraits and highest for full body and group photos. Detection accuracy for real versus AI-generated images follows similar patterns across these categories. We also randomized display time to the participants. At 1 second, people are 72% accurate, but within just 5 seconds, they boost by 5 percentage points, and with another 5 seconds, they boost by 10 percentage points. But as you see here, there is a very big distribution, and it totally depends on the context of the image. For example, when people are scrolling on social media and look at an image for half a second, they are more prone to make false interpretation of an image. Whereas if they slow down and view it for 10 seconds versus 1 second, big gains in accuracy can be seen. We also did an experiment looking at how human curation plays a role in photorealism. We randomly sampled 39 images from our dataset. For each image, we created about 12 regeneration of the same exact prompt. And so on the left is an image that we had chosen for the main empirical evaluation experiment, which had 37% accuracy. So out of this 12 regeneration, which was kind of an AI alone type of thing, best of them in terms of photorealism was this image with 42% accuracy. Then median accuracy image was this one, and then the least photorealistic one was this image. Maybe if you look at the hands, you'll know why. And so this gives you a sense of how human curation matters, and we're seeing that the left image really did have the kind of highest photorealism from this empirical perspective. Now, on the left chart, we are plotting on the y-axis the lowest accuracy out of 12 regenerated images against accuracy of the human curated image, and we see that the human curated images accuracy kind of match the best of the regenerated images. But if you look at the right chart, instead of the best out of 12, we look at the average out of 12, which is showing you that basically human curation is much, much better than the average generated image by AI alone. And so what this is saying is that actually human curation plays a large role in photorealism of today's diffusion model generated images. So I just want to finish by kind of showing that attention really matters. In this image, it kind of takes a few seconds before you see that the person on the right has in fact 3 arms, or there is a floating object on the table. All these kind of things emerge in our dataset, and so we're trying to think about ways to help guide people's attention so they can notice this kind of artifacts better. Thank you, and I can't wait to answer any questions.